Hello everyone, I'm Akhilesh and today I'll be performing a demo of the project which I have performed for the day Rapid Miner contest. This is the dataset. I have taken up a key DDC dataset from Kaggle and it consists of the following columns: age, BP, the pressure, the blood pressure, the hemoglobin content as follows. We had to perform a binary classification for this dataset. Moving on to the Rapid Miner part, I have imported the data set into the local repository and I have created all the processes here. So now let's look at each process one by one. The first process is importing the data set, and this is how the data set looks like. And moving on to the second part of the process, I have removed the missing values from the data set which we have collected. And after removing the values, we can see that it has all these values present. And here, if we look at the statistics of the data set, we can see that all the missing values here present are zero. Moving on to the third part of the process is exploratory data analysis, in which we perform exploratory data analysis on the data set given. Here, if we take the example set, we can look at the visualizations. This one visualization which I have drawn of pie or donut using the RBC count, which shows if that it is normal or not by plotting a pie chart. Coming to the part of the data preparation, I have selected the required attributes for the data from the data set which we require, and we have used a decision tree model to test the data set to find the accuracy. After evaluating with the help of the decision tree model, we see that these are the weights allocated for the top attributes which have been selected, and this is the decision tree split which takes place. You can see that hemoglobin is the top attribute which is used for performing splitting action, and this is how the modeling takes place, preparing of the model. And now we apply the model here, in which we can see that the model is being applied, and now the data set has been evaluated and shows the different weights which have been allocated here. And now performing the testing on the model, we find the following results. We find that it has produced an accuracy of 98.50%, and we look at the following results of precision, we call AUC or AUC curve, and all this. And coming to the part where we use the turbo prep to prepare the uh, data set, we find that we have used turbo prep to perform automated cleaning on the data set which we have used here. And we have finally used cross validation to perform the cross validation technique on this data set, and we have obtained an accuracy, higher accuracy than before of 99.83 here. Using turbo prep, we have created the AutoML model, and we have performed uh, results on different techniques. Now we will see the results which have been obtained by performing the evaluation on different models which have been proposed as a part of the AutoML model. These are the various attributes, these are the various models which have been used in this: naive Bayes, generalized linear classification, logistic regression, fast large margin, deep learning, decision tree, random forest, support vector machine, and gradient boosting algorithm. Now this is performing classification results, and now I shifted to accuracy over here. We now see slowly the results are being evaluated one by one. We see that naive Bayes has produced an accuracy of 62, generalized linear of 98%, logistic regression 88%, deep learning 98%, decision tree 91%, and gradient boosting 97%, and support vector machine 62%. Now all the models have been evaluated, and if we look at the results, we see that overview is shown here, and the ROC comparison curve is displayed as follows. The naive Bayes logistic, we see that the generalized linear model yields higher accuracy than the existing, and this is the curve of the lift chart, the predictions, the curve, the production missing values, the abnormal normal, and the models on each dataset and the weights which have been allocated. This is the demo which I have used to prepare this data analysis on this kidney disease dataset. Thank you.